Hello everyone and welcome back to my channel. Today we will continue our data structure series with binary tree program. Before moving on to the coding part, we first need to study something about binary search tree. Suppose here is a tree, binary search tree. Let's suppose we feed first data as 30. So root will take 30 and next we feed 60. So 60 is greater than 30, so it will go on the right child of 30. And next we feed 15. 15 is smaller than 30, so it will go on the left child of the 30. And suppose next we feed 75. Since 75 is greater than 30, it will go on right and it will check with 60, and since 75 is greater than 62, it will go on right of 60, and so on for the other nodes. For the coding part, we need to define a class node which will contain 4 variables. We will put these variables in an init function which will take a data as input, and the first variable will be data, which will be equal to data, and the second variable will be left, which will point the left child of the node, which will be initially none, and the third variable will be right, which will also initially be none. This will point the right child of the node, and the fourth variable will be the parent, which will point the parent of the node. It will also be none initially. Now we need to define a class which will contain the functions of the binary tree. It will also contain an init function. We will define root here, which will be equal to none initially. Now we will define an insert function to insert the data. We will take an input from the user. This input will be of integer type, so that we can compare the data and arrange it accordingly. We will put this data into an object of node class. Let's call that object as new node. Now we will check if root equals to none. Then we will put this new node into the root. Else we will call a function. So the function, let's call the function as underscore find insert. Let's call it as insert, that will be better. Underscore insert. It will take two inputs. One will be new node and other will be self.root, which will point to the current node always. So initially it will be root. Now we need to define underscore insert function with two parameters. Let's call the new node as nw and current as curr. Now we will check if current.data is less than new node's data. If that is so, then we need to check if current's right is equals to none. Since the data of new node is greater than data of current, so it will go towards the right of the current node. So if the right node of the current is none, then we will set new node's parent as current and current's right as new node. Now we will print data is inserted at the right of current.data. Else we have to recall the function underscore insert. We will pass two variables, new node nw and current's right curr.right, and that's it for this part. Now we have to check for another condition. Elif current dot data, we can copy this part here. We just need to change few things here. This will become greater than, and here right will become left, this side will also become left, and this side will also become left, and here in the print statement right will become left, and our elif part is completed. Now we will move to our else part. It means current dot data equals to new nodes data. Then we will print data already exists. We don't want to take same data again and again as input. Now we will define the display function. Let's call the function as display. Here we will be printing the tree in order traversal. So print tree in order traversal. Now we will create a new function. Let's call it as underscore display, and we will pass self.root in it. Now we will define underscore display. It will take it will have one parameter. Let's call it as current curr. Now we will check if current is not equal to none, then we will call the same function again, underscore display, and we will pass current dot left. Then we will print current dot data, and then we will call the same function with current dot right as its parameter. This will do first check the left child of the current node, and when it's find none, then it will print that data and it will move to the right node, and the loop will continue recursion. Now del node function, it will be used to delete the function's node, and we will take an input, an integer type input. Let's call it as val, the value of the node which is to be deleted. Now we will check where this value matches. So we will create another function, underscore del node. We will pass two parameters in it. One is self.root and other should be val. Now let's define this function, def underscore del node. It should have two parameters, current and val. Now we will check where our data actually exists. If current is not equal to none, if current is not none, we will move forward, and we will do similar things as we did in display. We will just check if current dot data equals to val. If that is so, then we need to check if current's left equals to none, equals to none, and current dot right is also equals to none. There should be no child of the node for it to be deleted. So now if that is so, then we will create a variable parent, and we will put value as current's parent, current dot parent. Now we will check if parent's data is less than the value. If this is so, then we will put parent's right child to be none, parent dot right child right equals to none, else. So that means data is greater than parent data. So we will put parent dot left equals to none, else. Now we can print here about the deleted node. Current dot data is deleted. Actually we should put this after it is actually deleted, so we will print it here at the bottom. Now we'll move to the upper if else, where if any child exists of the data, which means current dot left or current dot right is not none, then we will print can delete this node. We won't be deleting if it is none, not none. Now for the if, we will do an else, and we will check if inside the else we will check if current dot data is greater than val, then we will call the function and move to the right child of the data of the current node, underscore del node current dot left. Oh yeah, left, because value is smaller than the current, and else it means the value is greater than current's data, so we will move to the right child, current dot right comma val. Now we can copy this main function from here and paste it as it is. We just need to do one change here while creating the object. It will be object.p3, and this remove node will become del node, not underscore del node, del node. Now our program is complete. Now let's run the code. Here you can see the code. Now let's run. So it's working. I hope you have learned something from the video. Please like the video and drop a comment if you have any doubt, and thanks for watching.